function. But this particular example, you could use the cofunction. Now what the cofunction is if you take the cosine of an angle and the sine of its complement, then those two angles are equal. Because if we go to our unit circle and we look here at 30 degrees. So if I'm at 30 degrees and I want to take the sine of 30 degrees, that's equal to 1/2. But if I look at the cosine of 60 degrees, that's also equal to 1/2. So the 60 and 30 are complements. If I take the sine of 30 or the cosine of its complement, they're always equal. Think of that 45. 45 and 45 are complements. Complement mean they add up to 90 degrees. They're the same. The cosine of 45 or the sine of 45 are equal. So they're going to add up to be the same. We could take the cosine of 1 degree, and that's going to equal the sine of 89 degrees. And you add them together. So what that looks like on a proof, if you want to use it, is this. So if I saw that this was the cofunction ID, sine cosine of 90 minus x equals sine of x. This equals sine of theta. Keep the right. And my reason is cofunction ID. And I'm done. If you recognize it. If you don't recognize it, because you just can't remember what the cofunction is, you could use the sum and difference. We could say cosine 90 cosine theta plus sine 90 sine theta equals sine theta, and that's our sum and difference ID. Okay? Sum difference ID if we're writing our reasons. Again, you don't have to do it both ways. I'm just showing you if cofunction doesn't make sense to you, you can always use sum and difference. You never have to use cofunction. Now, I know what the cosine of 90 is because of my unit circle, 0 times cosine of theta. I know what sine of 90 degrees is, 1 sine theta equals sine theta. What did I do right there? I evaluated cosine of 90 and sine of 90. And now 0 plus sine of theta equals sine theta. Right there I multiplied. And now I'm going to add sine theta equals sine theta because of add. Either way works. You get to the same answer, 1 step or 4 steps. Doesn't matter which one you use. You still get the same answer. I've had some people, one of the problems on the quiz, I worked in 4 steps. Some of you worked in 6 or 7. I had one person work in 13 steps, and all 13 of her steps were good. Like she did something to get to the answer. She just did a lot more than what I did, which is fine. If you split things up, you might have 10, 12, 13 steps. You don't want that, okay, because you're not really seeing what's going on, but it still works. Just keep working. Always do something. You can't just look at these problems and say, I don't know what to do. Think about factoring. Factoring a trinomial, factoring the difference of 2 squares, getting an LCD, multiplying by the conjugate, taking out a GCF. All of those things you have to think about when you're doing these problems, because as soon as you do one, you might not see one like that ever again, and now you have to apply factoring to a problem that looks a little bit different. All of these things are continuing to come up over and over and over again. This is really kind of one of the easiest types of problems because there is only one thing to do. You don't have to think about, okay, do I use the ratio or reciprocal, Pythagorean, double angle? The only thing this is the sum and difference. Now, it's a little tedious and it's a little long, but it is very straightforward. One of the easiest proofs you could have. Remember, there's no such thing as distributing sine into something. We could distribute a sine theta into something, but that's not what we have. We can't just distribute a sine. This is the sum and difference IDs. So this is sine theta cosine 60 plus cosine theta sine 60. Now this minus is very important. We are changing this cosine theta plus 30 into two terms, two different terms. So minus parenthesis cosine theta cosine 30 minus sine theta sine 30 equals sine theta, and that was the sum and difference ID. Again, a little bit tedious and long, but not difficult. Only thing to do in this problem. Now, I'm going to do two things at once right here. Because I can do, if I see all these cosines and sines of 60 and 30, I know how to get rid of those. And I also want to distribute that negative out. So, here I have sine theta times 1/2. Cosine of 60 degrees is equal to 1/2. Plus, cosine theta I can't do anything with, but sine 60 I can. Root 3 over 2. Minus cosine theta times root 3 over 2 plus negative times negative is positive. See how that parenthesis is very important right there. Because if you don't put that parenthesis, you're never going to get to sine theta. You might get to sine theta, but you didn't get there correctly, and then nothing else is right after you mess up right there. Sine theta times 1/2 equals sine theta, and I evaluated and I distributed or multiply. Multiply by -1 or distribute that negative. I did both those things, so I have to write both of those things. You can do them in two different steps if you want, and that particular operation you can do all together. If you ever have to ask yourself, do I need to show this? The answer is yes, show it, because I'm going to say on test and quiz, you have to know that. So if you ever have to question, always write it down. Always write it down if you have to ask yourself that. All right, now, these two look exactly the same. One's plus and one minus, so that's 0. Here I have 1 sine theta times 1/2 plus 1 sine theta times 1/2. So 2 sine theta times 1/2 equals sine theta. And I added and subtracted. You could just say add. You don't have to say subtract. Subtracting is just adding a negative. You can always just say add. You can't say subtract in the place of add. So now I have 2 times sine theta times 1/2. 2 times 1/2 is 1. Sine theta equals sine theta. What did I do? I multiplied. I multiplied 2 times 1/2, which gave me just 1 sine theta. So again, a problem like that is a little bit lengthy, but those are the easiest proofs because there's no really question about what do I do. I just have to do what the operation says. Now I have to know the sum and difference IDs and how to expand them. So if I don't know that, that's a problem. But if you know them, then it's easy. You just evaluate when you can. If there's a theta or an x or a capital R, whatever that is, you just have to leave it there. This one, not so much easy, but when I look at that, we should all go right to the right side. That should be the side we manipulate. Do not manipulate both sides. You manipulate both sides, it's wrong. Minus all the points right there. Easy to grade. Not what we like to grade. Okay, we don't want to see that. So think about the side that looks the ugliest. That's usually the case. Now in the quiz, there were different problems. Some of you did the right, some of you did the left. Some of you did some things I didn't even think about that were really good, made it even a step less than what I did. One of them I did in 4 steps, but I had a few people do it in 3, and I didn't even think to do it that way. So there are lots and lots of ways to do these. It doesn't mean every way is right, but there are lots of things to do. All right, so when I look at this, right side, I have 1 minus tangent squared theta over 1 plus tangent squared theta. I cannot cancel. What's nice about a proof is those of you that still like to cancel those things, you will see that if I just start canceling, I am not going to get cosine 2 2 theta. I'm going to get, I don't know, -1 maybe? I don't even know what you think that you're going to get when you start canceling those things out. You're left with a random negative in the top and a plus in the bottom. So 1 does not equal cosine 2 theta, ever. So that's not correct. So if you do something and you get down to like a number, then you know you've done something wrong. The best thing to do on these is if you can't figure out what you did wrong, erase it and start over. Or get a new piece of notebook paper and start over. Because it's really hard to find one little thing. You mess up on one little sign, that throws the whole thing off. And it's just easier to start over. And that's for me too. I usually can't go back and find one little mistake I had. I just throw the piece of paper away and I start over and then I get the answer. All right, so some different things that we can do. 1 minus tangent squared. What's the only thing we could possibly do with that? Factor it. But if we factor that into 1 minus tangent, 1 plus tangent, does that do anything for us? No, because I can't factor the denominator, but that is something definitely to think about. And so the bottom I could change to secant squared. That might be something I could think about doing, so let's do that. Cosine 2 theta, 1 minus tangent squared theta over secant squared theta. And that is Pythag ID. That is something that a lot of you will see right away, which is good. But now I've got to do something with that 1 minus tangent squared. So again, factoring it doesn't really help me because I don't want to get 2 terms and I don't want 2 sets of 2 terms. So really the only thing left to do is we could change everything to sines and cosines. So I'm going to do that. Cosine 2 theta equals 1 minus sine squared theta over cosine squared theta over 1 over cosine squared theta. And right there I use my ratio and reciprocal ID. I use them both. Now I could multiply by the reciprocal right here, but that numerator has 2 terms. So if I do that, I have to be careful to distribute that denominator to both terms, which is fine. We just have to make sure that works. So is that something that we should do? Multiply by the reciprocal? Or what else could we do? Same denominator? Okay, I like that. Cosine 2 theta equals cosine squared x, or theta, over cosine squared theta minus sine squared theta, and all over 1 over cosine squared theta. That's a good thing to do right there. LCD. Now, some of you know that when you see all of your denominators are the same, okay, we can really kind of, I don't know, let's see, what would that be called? Divide. So we're dividing, multiplying by the reciprocal. I'm going to go ahead and combine that numerator. Some of you know that you can just get rid of your denominators there. Some of you don't know what I'm talking about when I say that. So I'm going to make the numerator cosine squared theta minus sine squared theta over cosine squared theta. That was my numerator. And I'm going to multiply by the reciprocal of the denominator. So I subtracted and I multiplied by reciprocal. So right here, cosine squared theta minus sine squared theta, I subtracted those, and I multiplied by the reciprocal. I did not do 2 things to the same thing. I did something to the numerator and something to the denominator, right there. So now, cosine 2 theta equals cosine squared theta minus sine squared theta. Cosine divided by cosine squared is I divided cosine squared theta divided by cosine squared theta. And now I have my double angle ID. Cosine 2 theta equals cosine 2 theta because of double angle ID. Not the only way to do that. Hey, I think that's the third different way I've done it today. So there's at least 3 different ways to do that. I'm sure there are more. Do not skip any steps. Like, we can't go from here to here. That would be skipping a step in between. Okay, we would want to show each step. If you have to ask yourself, can I skip this step? The answer is no. Maybe it's yes, but on a test or quiz, during notes, homework, classwork time, absolutely say, is this a step I could skip? I will absolutely tell you yes or no. But when it gets time to test and quiz, if you have to think to yourself, do I skip this step? Don't skip it. Write it down. And you can't do work within the problem. Like, you can't work, have a proof, and remind yourself what the Pythagorean idea is, and do some work on the top, and then do some work on the bottom. It's got to all stay together all the time. You can't lose anything in a proof. All right, another one. It's got some double angles in it. So we have sine 2a and we have cosine 2a. The nice thing about sine 2a is there's only one thing to do. 2 sine a cosine a. That's all we can do. But this cosine 2a, there's 3 different things we can do. And we might pick something, and it might be the right something, it might be the wrong something. If you pick it, and you've done everything that you can do, and you can't think of anything else, you might have to go back to the start and pick one of the other options for cosine 2a. Now, when you're doing this, sometimes, especially when it's a proof, we can kind of think. So cotangent A, if we think about our ratio ID, cotangent A is equal to what? Cosine over sine. So there's a sine in the denominator. So we probably want to put a sign in our denominator, which would help me pick maybe the correct one. So when I go back and I look at my IDs, I have these 3 options: cosine squared and sine squared, just cosine squared, or just sine squared. Since I know I for sure need a sign in the denominator at some point, I'm going to pick that last one. Maybe it's a good choice, maybe it's not. So I'm going to choose 1 minus 2 sine squared A. I'm going to go ahead and just write cotangent A, and the reason I was able to do that, double angle ID. Some people have been writing that twice. They write double angle times 2. You don't have to put it times 2. Once you do something, no matter how many times you use it in that line, you don't have to tell me how many times you did it. All right, so now I just need to clean this up a little bit. So the top I can't do anything with. It's still just 2 sine A cosine A. That denominator, I can distribute that negative. All I did right there was distribute or multiply. Multiply is fine also. Distribute and multiply, interchangeable. And now I have a 1 minus 1, so I can say 2 sine A cosine A equals 2 sine squared A. All I did was subtract. If you like add, you can say add 1 plus a negative 1. I added also right there. Or instead of subtract, added or subtracted is fine. You can say subtract. You can say add. If you want to always say add always works. Subtract does not always work. Now, I'm going to show one more step right here, because a lot of you are doing this, and I like it. I think it's helpful to most of you 2, I can make that sine A, sine A. And that's called an expand or a rewrite, because I didn't really do anything. I just changed sine squared into sine times sine. And now, see how all those things add up? 2 divided by 2 is 1. Sine A divided by sine A is 1. Cosine A divided by sine A is cotangent A equals cotangent A. I did two things there. Divide, and I use the ratio ID. Because the 2 divided by 2 and the sine A divided by sine A was divide, and then the cosine A divided by sine A was divide, but more particularly, it was the ratio ID.